the show. Ladies and gentlemen, hello and welcome to another episode of Handmade Hero, the show where we code a complete game live on Twitch. No engines, no libraries, just us and our cunning to the extent that we do have it on certain days. Admittedly, some days are better than others. Not everyone is cunning all the time. Sometimes you're only half cunning or a quarter cunning. Heaven help you on the days when you're negative cunning, but it happens to everyone sometimes. And I'm sure it's happened to us already. In fact, I'm pretty sure it has happened to us already, and it'll happen to us in the future. But maybe we can avoid having today be one of those days. Because I thought of something last night when I was going to bed. I thought of something about what we have been doing that I think is an improvement, and so I wanted to talk about it today. It was kind of an obvious thing. I had not thought about it in this way before, but I am thinking about it this way now. And so, yeah, I'd kind of like to go over it with you and see what you think. Before I get started, however, let's go ahead and say that anyone who has pre-ordered the game on handmadehero.org should have gotten a link in their email to download the source code. So if you want to use that source code to follow along, today is day 78. So what you will want to do is unzip day 77's source code out of the zip file, and that will allow you to follow along with exactly the same source code I'm starting with today. So let's get started. Here is the thing that I thought of yesterday that I probably should have thought of, but sometimes it's better if I don't think of these things. I mean, one of the nice things about the fact that the stream is periodic and I'm not thinking about it all day, I only think about it, at night or whatever, is that I don't come up with things perhaps as quickly, and that allows you to see me do something less good and then move it towards something better. We've already seen that happen with a bunch of stuff like the sim regions, I think, with that, and the tile chunks or the world chunks and so on. Like we've constantly had that kind of happen, and some of those were intentional. Like sometimes I intentionally start out with something simple rather than guessing at the final sort of good thing and trying to go directly towards it because I want to show it. But other times I'm legitimately just going, well, I need to do this now, let's try something. And then later I kind of figure out, oh, that would be better to do. And so this one is something that I guess I kind of should have known, but honestly I just did not even really think about it at the time. And so I'm going to think about it now. So what we were talking about yesterday is we were talking about having this notion of a ground point, right? And so if I imagine an entity is occupying space in some way, right? Like so. And we were talking about, having these sort of bounding boxes and that sort of stuff, and we did collision detection on them, and we've got all that working, and it's good. And they're 3D and all that, and so it's kind of nice because it means we can support more stuff in our game, like smoothly going up and down stairwells and maybe fading things in and out and having kind of nice level transitions or looking at things below you. There's all kinds of stuff that we might want to do in the game, so it's kind of good to support that, and it was just good programming exercise. Again, since this is an educational stream, it's a good programming exercise to just handle the 3D relatively well instead of totally cheesing it always. And so I'm glad we did that stuff. What we got to is we got to a point where we were saying, well, if we have bounding boxes and we want to treat them kind of as sort of symmetric things where we're saying, okay, there's a point that's the center of the bounding box, and then we have dimensions out in the direction of the corners of the bounding box, right? So we basically have radii, that kind of do this sort of thing. So we have like an X radius, a Y, oops, that's a Z radius, and a Y radius. And then we've got the point that's at the center. When somebody is standing on the ground, we realize, well, we've got to have this notion that down here is actually the point that actually needs to be on the ground, because making the point where the player's location was that the bounding box was centered around be the point that we track on the ground will make this bounding box sink into the ground, because it means that the ground level will be there as he moves along it, right? And that's no good, right? That's not what we want. So we introduced this point on ground concept, and then we had everything follow that. Now, someone pointed out, actually, in the post-stream Q&A, they asked, well, since we're doing all of that computation with that ground point, couldn't we do something where we have where we kind of refactor things so we're always using that point instead, so we don't have to constantly get the ground point and so on. And I was like, well, we sort of thought about doing that, and the problem with that is we want these bounding boxes to be handled symmetrically. Like, we don't want to have it so that just Z is handled differently. And so we could have done something like always had the minimum corner and that would have meant that that was the point. But then that doesn't really make sense, because typically when we're thinking of where you have to stop when you're walking, we typically think of that as being roughly where your legs are, not all the way out at the outside of that bounding box and so on. So we typically are thinking about the center a little bit more for most of the things that we do. There's just a lot of reasons why that would also be kind of janky, and so, you know, there's some jankiness there, right? There's a jankiness problem. But what I realized is I was kind of missing what's sort of an obvious solution to this problem, and that is something that we do in 3D all the time, and for some reason I just wasn't thinking along these lines, so it's not the first thing I thought to do. And that is basically that, you know, the position, right, is not the same thing, you know, as your collision, right? We call this a collision mesh oftentimes in 3D. Basically, your position is some logical notion of where you are that the AI uses and the game uses for things that it wants to do and blah, blah, blah. But that's not the same thing as collision at all. And in 3D games, what we typically will do is, you know, we might have some notion of where an entity is. You know, in space, we might say, you know, here's where an entity is. But actually, the collision volume for that thing is like a whole human. And it's like meshes that are like, you know, the torso. And then there's a mesh for, you know, the legs and all these sorts of things, and arms and blah, blah, blah. And each one of these is its own rigid body that might be used for physics, and that has a collision volume associated with it, and all this extra stuff. And so what we do is we essentially store a list along with that position, right? As part of the entity, we store a list of all of those pieces, right? We sort of say, oh, okay, well, yeah, he's got a position, but then he's got an arm, right? And the arm is at some offset, and it's got some dimensions, and it has some collision mesh or whatever. And then we've got another arm and a head and whatever. And so what I think probably we should have done, and what I think I'd like to do today, is say, okay, we have an entity position, and that entity position is going to be on the ground. So we can get to that thing that the person was asking about in the post stream yesterday that they would have liked, and that I would have liked too, but that we didn't really think we could do cleanly, which is we just think about the position of the guy as not having to hover above the ground. It's right on the ground, and it moves along the ground. We do have that, and that's the position of the entity. But then the entity also has a set of offset bounding boxes, as many as they want, right? Which are those collision meshes. So it could have 2, right? Or 3 or more, right? It can have as many of these pieces as we want it to have, right? And so that way, when we're doing a collision detection, when we go through the dude, we do the collision detection actually on these pieces by iterating over the pieces that are inside of the guy one at a time and doing collision detection on them. And then the combined result of that collision detection is what we decide to move the guy by, right? So essentially that's, you know, a really easy way to get around this problem that also adds features to our engine. It allows us to have multiple collision regions so that if we have people who are not, like, let's say we want to have everything broken down into convex shapes, which I said was pretty much the only way to reliably do collision detection most of the time. If we want to break things into convex shapes, you know, and we have a guy who kind of looks, you know, roughly like this or something, top down, we can just add 3 different collision volumes to him, and that'll just work, right? We don't have to do anything special about that. So that actually adds features to our engine as well as solving our ground point problem. And so that to me seems like a pretty compelling way to get the best of both worlds, to both get the thing that we kind of thought we couldn't get but wanted, and also add some nice features. So that to me, again, seems like the right way to go. So let's take a look at that. I think it would be a good idea for us to take a look at that. All right, so let's go ahead and open up Emacs. And so if I go in here to Handmade sim region and take a look, I believe my entities are still in here. We should probably at some point take the bold step of moving the entities out into the entity file, but yeah, you know, not really a big deal. So if we take a look at this sim entity, we've got sort of these fundamental motion things here, and then we have this dimension. And so what I'd like to do is I'd like to go ahead and make an actual, you know, make it so that you can actually have this dimension thing be offset. And so what I'll do first is, since we don't have any need for multiple collision volumes at the moment, I'll just do one collision volume. And then when we kind of go in the future and decide how we want to deal with stuff maybe a little bit later, we'll just have everything, sort of set up so that it can handle the multiple ones if we want to, if that makes sense. So I'm going to go ahead and say, for now, we'll just say struct sim entity collision volume. I guess there's a little bit of a question here too. One of the things that we can decide, and I don't really know which is a better decision here, but it's a little bit hard to say. One of the things that we can decide too here is we don't really know whether we need this to be entity-based storage or not. For example, if our entities, just to kind of let you know what's going through my head here. So let's take this example of a guy. This is a top view here of this guy. If we take this example, there's two ways we could store this data, right? We have an entity structure, right? This is our entity. And inside that entity, we could either directly store inside it or have a pointer off to, right, a thing that's basically a list of collision volumes, right, for that guy. And whichever one of those we do, like let's say that we take the one where we just have a pointer off to a list. Maybe there's a count and there's a pointer to a list. The question is, does this live with the entity or is it shared, right? Meaning, is this something that we need to track per entity, or is it something that entities can share between them? Because, for example, if we had lots of entities that all use this exact same shape, maybe we never need to store that, right? There could be some other entity, and it just points to the same list of things, right? Because it's the same type. These are both the same kind of monstar, so they both have they both just have this description. That works very well if it's always going to be the same. If, on the other hand, every entity has a slightly different one of these, so every monster, this is slightly bigger or smaller, like some of them have a chunkier midsection and smaller arms or whatever this is supposed to be, like that, then sharing doesn't really work anymore at that point. Each one of them wants its own unique one. And I suppose at this point we don't really have to think about that too hard, but what it does suggest to me is maybe I'm going to point out to it. And I'm just going to assume that most of the time this will probably be shared, but we can always just point out to unique ones if what ends up happening is most of the time they aren't shared. So I'm going to say that we have some kind of a structure here, very simple, like again, that's just storing exactly that same data that we were storing before. And so it's something like this, where we basically have a count. So we have a volume count, and then we have a sim entity collision volume, just volumes, like that, right? And I don't really have a real reason why I'm breaking that down into 2 hops there. Maybe that's stupid. It could be that it's smarter, again, to compress that upwards, but that's really an optimization concern, and we don't really have to worry about that too much. We can obviously make that decision a little later on. So for right now, what I'm going to do is I'm going to replace that dim, since there is no such thing as dimension in particular anymore. I'll replace that dim with essentially a list of dims. So we're going to point to a collision group here, and we're just going to say that there's a collision group off of the entity. Right? Very simple. So we've got the collision group off of the entity. We have the dimension of it, and so all we need in addition to that is some offset that lets us know that from whatever the entity's position actually is, where is the collision volume relative to that, right? Because that is the thing that lets us know how to actually do colliding. So that's it. That's really all I wanted to do. And again, we could decide to make it to do that, which would embed it directly in, and then there would be, that wouldn't really be the same kind of sharing, although they could still share these pointers. But let's say for now, I'm just going to say for now, that the way that we have this work is they all point to some group that's been constructed for their type of guy. And we're really not going to make distinct ones of those at the time being. So it's sort of like it's sort of like an entity type almost. In fact, at some point, maybe we will even compress this down further and say that we just use the entity type directly to get the collision group for that entity type, and there aren't specific ones. But for the time being, we'll we'll leave it this way because it will let us vary the sizes of things a little bit more and be a little bit more crazy with that. So we'll leave it in until we decide we really need to compress it down. All right. So what I'm going to do now is I'm just going to compile the program, and I'm going to let the compile errors guide my replacement of the dimension, which is something you've seen me do a lot. And it's a good programming technique. It's basically you replace something and just let the compile errors tell you all the places that you need to think about it. All right, so for getEntity ground point now, really that's just there isn't gonna be any more displacement. That's just automatic, right? The ground point is whatever the position of the guy actually was, and anyone who's using that will just get the right thing back, and that's fine. For figuring out what the stair ground is, in this case, what we would like to do, excuse me, is we'd like to say, well, we should see which point you are inside, right? And that's how you would get the stair ground. So because let's say a stairwell had multiple pieces, multiple collision pieces to it, we want to see which one you're in, and then we want to get a barycentric thing out of that. So, well, actually, now that I think about it, actually for stairwells, we want something slightly different, which is actually that we only care about that sort of footprint, that XY footprint. So really what we probably want is stairwells just to have an extra thing, since their collision is not really necessarily related to that. What we might want to do is just say we've just got a notion of that barycentric piece, and we go ahead and construct that specially. So I think I'm just going to go ahead and make that change, and we'll just test it later. So basically what that means is in SimRegionn, again for these guys, I'm going to say that we have a rectangle too. That's basically the walkable region, right? And that's the area where that height happens, essentially. And in fact, what I guess we could do is we could make a rectangle. We could even make a rectangle 3 here and say that stairwells have a volume that has nothing to do with collision, that just tells you about how you move in them in that way. I'm not sure if that's useful or not, but we could have done that. For right now, I guess we don't really need to do that. Do we want to do that? I guess we don't really need to do that, so I won't. We can think about stairwells in a little bit more detail later, but what that means is this region rect this region rect is really just an offset rectangle, right? It's just the walkable region I should say walkable dimension. It's just the walkable dimension, like so on. It's just a rectangle that's been centered about the point of the guy in 2D, and it's using the walkable dimension as its size. And so we'll get the barycentric coordinates out of that and use the barycentric y to determine the motion of it. We could also have stairwells going the other direction by using the barycentric x. In fact, there's a couple things. We could even make very odd sort of slanted surfaces by actually having sample points. Oh, that would be even weirder. I'm not going to think about that for now. Yeah, we could have weird sort of scallopy surfaces. Yeah, that's something for, maybe we'll think about that a little more with ground height. Anyway, so if we get our barycentric coordinates back using the 2D rectangle now for that ground point, and the ground point actually now is mostly just going to be used for the x and y. We're going to get back that result, which is how far up we should be, and we're going to do that from whatever the entity's position is. That's how we'll define it for the stairwells. So we'll keep going here. Rectangle centered dim, probably we don't have that yet for 2D rectangles. I'm imagining we only have that, rect center dim. I'm imagining that we, oh no, we do. So what's the problem? Oh, right, duh. That doesn't need to be a rectangle. That's just a V2. That's the walkable dimension. So let's see here. Clamp 01, or what do we got? Get barycentric. Okay, so our get barycentric, that is the one that actually doesn't have. Yeah, so we need a get barycentric for our rectangle 2. That's pretty simple. That's just reducing it down 1. We just don't do the Z. So that's, really, really basic. So we've got that done. And their safe ratio stuff, that really should be defined up at the top. So, because, oops, everyone needs to be able to use that. those are just scalar operations. So that should be along with like these sorts of things, clamp and lerp and those sorts of fun things. All right, so let's see here. Get barycentric. What did I do? Get barycentric. Still a rectangle 3, which is not what I wanted. So let's take a look here. Get barycentric, clamp 01. So clamp 01 is just a v3 special function. So again, we'll do that in v2. And for those of you who were using templates here, again, this is stuff you wouldn't have to do if you're using templates. Like I said, I don't like to use them. I prefer to just do the copy paste or to go the full metaprogramming route. I always pick one or the other. I don't pick the template route, but if you're doing the template route, hopefully your templates, hopefully you did it right. Those should have just been generated for you, hopefully. I suppose you could have done something bad, but assuming that you did it reasonably, that wouldn't be necessary. Okay. So, now we get to stuff that actually is doing more of the collision detection. So let's see here. What we need to do is see whether our entity overlaps the bounds that we have. And so I believe all we really need to do here is test those regions. Now, it's unclear whether we want something faster here. You know, when we do entity overlaps rectangle, and we pass in that v3 dim, really, you know, presumably we might still want the concept. And in fact, this is something I guess that we could do, is say that the volume group itself stores, you know, its own total collision volume. So we have like a total volume, and then we have individual volumes, so that basically there is one volume that encloses everything, and then we have other volumes that are, you know, sort of subchunked. And in the case where volume count was 0, it would mean that your entity didn't have a more complex shape to it. But in the case where it was, then you would do subtesting. And I think I like that because, for example, in entity overlaps rectangle, this is not a gameplay concern. This is just a region gather. And so it seems like a waste of time here to go through and figure out, okay, is he really overlapping exactly? Or is it that there's like a little convex part of him that's not overlapping? That's something we do care about for collision detection because it affects the playability of the game. It's important. But in terms of figuring out what's inside a sim region, I'm not sure we care about that. So I think what we want to do here is say that we've got a collision group. And that collision, maybe I'll just call that collision. It doesn't really need to be collision group, probably. We'll say that we've got that collision. We'll just look at the total volume, right? And we'll pass that total volume and say that's, you know, that's the thing, right? And so then inside our entity overlaps rectangle thing, what we'll do is we'll pass one of these collision volumes, like so. And we can go ahead and pass that in. And what we'll do is we'll take that volume, and I guess, well, we could pass it by value. It seems like a little bit large. Well, that's an inline, so I guess that's fine. So it'll understand what it needs to do there, probably. I don't know. That's one of the ones you probably want to check. But anyway, so we'll pass in that volume there, and then what we'll do is we'll do the checking against that volume. So the first thing we need to do is say, all right, we need to actually grow the rectangle by the volume, which we're going to do exactly the same way. So this should work exactly the same way. But then when we do is in rectangle p, it's not just the entities p anymore. It's actually the p plus the volume offset p, right? Because we're essentially saying that, you know, the actual point, the location that we're testing is this offset version. So I think that's all we really have to do there. Yeah, I don't think there would be anything else. We're enlarging the rectangle and seeing if we're in it. Yeah, I think that's about it. So that should be fine. What's the problem here? Does not have an, oh, you're right, it does not have an overloaded. I'm still thinking I passed it by pointer. So let's see. Dimension is not a member of sim entity. You are correct, it is not. So in entity overlap rectangle, this is the same kind of test that we're doing here. So we're just going to say that we're going to pass the collision there again. let's see, cannot go to we need the total volume, like so. And then we now have our Minkowski diameter. Let's see, we've got our dimensions here. So now inside, this is actually the collision loop, and it looks like, why is this saying it cannot recover from previous errors? Really? It was so hard to recover from the fact that we don't still have that dim in there? All right. Well, anyway, point being, what we want to actually do now is we want to go ahead and test those collision volumes, those sub-collision volumes. And so the way that I'm going to do that is, really, all I have to do is enclose this in a loop and test each one separately, right? But there is one little caveat, which is that the total volume, if there was no volume, do I really want to store it twice? You know, I guess the answer is we'll do that for now, but just trying to give you what the idea is. So if we have a total volume and we wanted to be able to make an optimization, which is that if we set volume count to 0, then the volumes themselves would be ignored and you just use the total volume as the actual volume for testing, right? I don't know if I want to do that short circuit or not. For now, I'm not going to. So for now, I'm going to say volume count is always expected to be greater than 0 if the entity has any volume. In the future, this could be compressed if necessary to say that the volume count can be 0 if the total volume should be used as the only collision volume for the entity, right? And so that's just like a short circuit thing. I'm not gonna do that. I'm not gonna do that. All right. So let's go ahead and bump this out like so. And I'm going to go ahead and iterate over those. So we've got another loop in here, and that's going to be the volume index, right? And this part is actually, I mean, if we actually want to do this correctly, it's a bit difficult, right? It's actually 2 loops, right? We have 2 entities, each of which might have n number of collision volumes. So it's really an n squared pairing. And unfortunately, that's collision detection in a nutshell. Collision detection is unfortunately an n squared problem. And so a lot of the stuff that we do in collision detecting, and you'll see us have to do this when we do the full collision detector in the end, is we try to eliminate a lot of entities right off the bat because of the nasty n squaredness of it. And what I mean by that is, let's say that I've got, some things moving in the world, right? Well, for every set of things, the computer can only really consider pairs of them at once, right? It can ask the question, will this guy collide with this guy? But once it computes that answer, it has gotten no further in determining whether this guy will collide with this guy. So for every dude, it has to be checked against every other dude. And that's the textbook definition of an O(n) squared problem. When however many of these you have is n, and you need to check for every one of them against n, all the others, that's n times n pieces of work you have to do, or n squared, right? And that's that order notation stuff. We've never really spent a whole episode talking about it. But order notation is really just a way of saying how the work scales, right? How the work scales with the number of units. And so as that number of units goes up, n squared things look nasty. They look like that. So there's a certain number out that you can do, like 100 of them or whatever. But when you get to 1,000 of them, it may be really tough. And if you were to get out to 1,000,000 of them, forget it. It's never going to happen. You're never gonna, it's like a non-terminating program that runs for weeks or something, right? And so, it is at collision detection n squared. There's not much we can do about it. And you can see it. happening with loops inside loops, and so that's exactly what's going on. There's just collision detection has a lot of that in it. And so we have the entity's volume index to loop through, right? And then we also have the test volume index. Oops. The test volume index to loop through. And really, in each case, that's what we have to do. We have to look at each of the entity volumes. So we have the entity collision volume count to loop through here, and we have the test entity's collision volume count to loop through here. And then this internal routine actually has to be made to work off of both of those so that we test pairwise each individual one. Now, this won't actually lead to any more actual work in our case at the moment, because there only will actually ever be one volume in the volume count. But if we were to increase that volume count up further, then it does multiply that, which makes it so that it's pretty expensive to have lots of those volumes. But that would have been true if there were lots of entities as well. And again, collision is an n-squared problem, and it's tough that way. So you typically try to do a lot of sorting of things into places to figure out whether they could ever possibly hit each other, so that you keep n very low. Because when you have an n-squared problem, the only way you can really ever solve it efficiently, especially in a game context where you don't have a lot of cycles to spare, is to keep n low. That's what you have to do. So you have to use techniques to keep n low. For right now, our n just is low, so we don't have to worry about that. And hopefully the n always will be pretty low for these, because there shouldn't be like thousands of collision volumes in an entity. There are these little things on the screen. I mean, how many could you need? 3, 4 should be pretty low, right? So that should be okay. But at the outer level is where we'll definitely do it. Like this loop is not going to stand. It's because we're calling move entity on lots of entities per frame, potentially, and each one of them is looping through all the other entities, even if those entities are fairly far away from them. They're looping through all the entities in the sim region. Now, the sim region is keeping it down to a smaller n, much smaller than all the entities in the game. So that does do a big part of that for us. That got n down from 10,000, 100,000 entities down to like 100 or 1,000 entities, but we can do much more granular. Inside the sim region, we can have things partitioned further to cut that n down further and get rid of that nasty n-squared feedback. So that's why I have to do space partition here, is because that probably is something that we're not going to want to leave in the shipping product. In the final version of the collision detector, that will go away almost certainly, unless I end up being very surprised by how our profiles look. Anyway, so when we loop through these, what we need to do now is set up the collision between the entities' bounding volumes rather than themselves. And that's not that hard to do. Really, all we have to do is pick out those two volumes, right? So we'll have the entity volume here, and that'll just be their collision volumes, volumes plus entity volume index, like so. And then in here, same thing. We'll just do test entity volume like that, and test volume index, right? And I'll just call that test volume. I don't need to put entity in there. So that'll grab out the two volumes that we're testing against, and now we just need to actually use those instead of their correspondence. So instead of the entities where that used to get, we'll get the dimensions now out of the volumes, right? I guess we could just call this volume as well. Volume and test volume. There we go. Don't ask me why I'm doing this renaming. Yeah, it's probably not that necessary, but I'm doing it anyway. Okay, there we go. So that'll produce the correct diameter for us, the two volumes versus each other. That's what we wanted. And that'll produce the min and max corner centered around the test volume, just like we were doing before with the test entity. But now this has to change because these entity P's are not proper. What they need to be is they need to be offsets. So we need to look at the entity P plus the volumes offset P, right? That's the position of, that's where it actually is in 3D space. That's where that collision volume is in 3D space. And then we also have our test entity P. That's going to be plus the test volumes offset P. And now we've just basically created two entity bounding boxes, just like we had before, but they've been offset. And then we're just going to do the collision detection exactly how we were doing it. All the rest of this stuff should just work. There's really not anything else to it. I think that's pretty much it. I think that should just about cover it. Let's double check. Yeah, so that just went ahead. And resolved all of those, it looks like. So now we're on to other things. All right, so now what we wanted to do here is see whether the entity rectangle is overlapping basically any of these sorts of, any of these other pieces that we need. So this was to handle our stairwells, right? This was to see whether we were overlapping the stairwells. Man, I'm out of T. Look at that. How am I supposed to program with no T? Seriously? I tell you, that is one thing we definitely need here at handmadehero.com. If we were a .com instead of a .org, then we would have the billions of dollars of venture capital funding, and then we would have the huge fancy kitchens with and special people whose job it is just to bring me tea, right? That's what we would actually have. Everyone knows that that's how you run a company. If you want to do it right in Silicon Valley, you have to have at least 7 gourmet kitchens per programmer. How are they supposed to get any work done without gourmet teas, hand brewed, preferably by special robots designed by NASA. All right, so let's take a look here at what this is doing and see if there's anything in particular we want to change about it. I think for now we can probably just do we can probably just do the same looping. I don't see anything particularly odd here. We just do rectangles intersect on all the things, right? And yeah, it's a little bit of a bummer that we have to make rectangle the rect center dim stuff, but we could try to rewrite this loop to be a little bit cleaner as well. I'm gonna go a little further down. I'm gonna leave that one for now, and I'm gonna think about that for a little bit as to how much we want to rewrite that. So I'm gonna go ahead in here, and I'm gonna deal with this instead. So what I'd like to do here is I'd like to just create some of these and just use them directly for things like our swords and our player and stuff. So what I'd like to do is in our game state, I'd like to create these things as sort of templates that just get used, not like the C++ template, but templates like in the traditional sense of the word, that get used in creating sort of the players and the sword and the monster when we create them. I'd like to go ahead and make these volume groups be those things, right? And so what I'm going to do is I'm just going to make some of those here, because why not? So what I'm going to do is say we've got a volume group pointer for swords. We've got a volume group pointer for stairwells, right? We've got one for players. We've got one for the Monstar. We've got one for the wall. And we'll just sort of use those as we go. And so inside handmade.cpp, when we create stuff at the beginning, I'm just going to go ahead and create those here. And I'm going to use just a utility function basically to make them en masse. So if I go in here and I guess I'll use our game state's permanent storage for this. So I'll go ahead and say that the sword equals make simple collision, and that'll just pass the game state, and then it'll pass this stuff, right? So a sword will just take what its dimensions were. So its x dimension was 1, its y dimension was 0.5, and its z dimension was that. And we'll make simple collision based off of that. And I believe, well, I guess for a sword we don't really care, but I believe the rest of these people, it was always being offset from the base. So we'll call this make simple grounded collision. And what that'll do is that'll automatically offset it up by half the z height like we were doing before. And basically everyone can use that, right? For now. Okay. So for S-word, when we do this collision, what we want to do is say that the entity, oh, there's one more we should have. Duh. Sim entity collision volume group null collision. We want that too for anything that just doesn't want to collide at all. And that'll just basically have an empty collision volume and no actual volumes in it. All right, so I want to make that as well. Let's go ahead back here to this guy. So when I add the sword, I'm just going to take its sim collision group, and I'm going to point that at the one for the sword. And I realize I should probably do collision on the end of all of these, huh? There we go. So sword collision, right? That's it for that. And I'm going to do the exact same thing with everybody else. You know, not rocket science here, right? I wish I had the same number of columns as I do at work. It's hard. I like having my code be long. I don't like it have to keep breaking lines like that. It's annoying. But anyway, all right. So let's go ahead and make all these. Gamestate sword collision. Oh, that helped, didn't it? That'll help me with my line break problem. I love it. All right, there we go. And when you're verbose with your naming, like I am, you end up in that situation where you really want you want your lines to be long. You know, what can I say? It doesn't really lend itself to this Twitch streaming where everything has to be big so it can be legible on the stream. This is, I typically have a lot more screen real estate, functionally speaking, when I'm working, and it does make it a bit tougher. Anyway, so let's see here. We've got our S word. There's our wall. So these guys are actually for add grounded entity. Yeah, so now we don't really need add grounded entity anymore either, which is kind of nice. That will just get taken care of for us now because all the entities will just work at that point. Yeah, so grounded entity doesn't have to happen. And that's kind of nice. But let's finish up what I was doing here. So when I do add wall, let's see, where is wall? There is wall. Here is the dimensions to that, right? So what I'll probably do is say, we'll just make add grounded entity take that Gamestate wall collision, and it'll set it for us, I guess. I don't know. Seems reasonable enough. Our stairwell, same thing. So here's the stairway to heaven, of course, the place where all stairways go. It's about a 7-minute long stairway. It's played on classic rock stations all the time. Everyone's bored of it by now. You know how it is. Okay. So let's see. That fixes those guys. Add grounded entity just takes one of these. Again, that's a really easy simplification. That's a sim entity collision volume group, right? Group, or collision, I should say. And then in here, it says that the collision equals that pointer. And then it doesn't have to do this map into chunk space thing. It doesn't have to use offset p. It just does it, right? And similarly, it doesn't have to set the dimension because that's already handled. And yeah, that should just work. So that looks all good. We have our add s word as well, and we have our add player. Our add player wants to have, and so I think we started, what did we start, 15 minutes late today? Because I was ranting about low quality software. So I guess what that means is we will go 15 minutes from now. So we'll have to keep an eye on that. So 9:15 is when the stream will actually begin the Q&A. Make simple grounded collision for the player. Now that's in there. Instead of passing that, it'll just pass Gamestate player collision, like so. And then the Monstar, also put his dimension in there, so the Monstar can participate just like everyone else. We are an equal opportunity grounded entity adder. We do not discriminate against Monstars simply because they are Monstars. Monstars have rights as well, and it is important to treat them with dignity, and so we do. So I'm going to skip this again because that's what I want to come back to in a second. All right. Oh, familiar. I forgot about the familiar entirely. how dare I? Familiar collision. And so familiar collision. Yeah. And let's see. So sword collision. So I'm going to go ahead and add that in here. Familiar collision. Make simple grounded collision. And I mean, hopefully you can see that I'm not doing anything weird here. I'm just simplifying things down to a basic simplification that I'm doing. Nothing particularly unusual going on here. All right, that's supposed to be sim.collision. And what do we got here? So this is just our rendering stuff, which we have to clean up. And so let me go ahead and do that as well. So what we're doing here is we're actually taking a look at that ground point. That's actually going to be fine now, so we don't have to do this anymore. That'll get rid of that. Again, making it nice, just like the person was asking about in the post stream yesterday. Let me see here. Inside here, when we're doing a stairwell, what we want to draw on the stairwell is actually going to be a little bit different than what we were drawing before, right? What we're going to draw on the stairwell now is we've got that sort of walkable dimension that we're talking about, this right here. And so what we want to do there is we want to go ahead and push some slightly different stuff than what we were pushing before. It looks like really we just want the walkable dim directly as itself. Its Z value in terms of where we want to be offset in Z is just going to be that walkable height, right? Which is we also know that's how high off its ground point it goes. And again, that's just going to be the walkable dim again. So we're just drawing that using the other things now instead of treating the collision volumes as that definition of the stairwell. And then it looks like everything else worked okay. So what I'm going to do here, I'm going to temporarily disable this guy. And then, because I think we might have our hands full with debugging stuff, you know, correctly in the short amount of time that we have left. We've only got about 12 minutes left. So I want to focus on getting everything else working, and then we can sort of think about that thing. Maybe we'll do that tomorrow before we do. Ooh. Control Z, everyone. It suspends Emacs as if it were Unix, even though you can't really suspend something. Oh, got a sore shoulder today. It happens. So here's our dimensions, and this is our thing for making a simple grounded collision. So I'm going to go ahead and push that on the arena. Of course, I don't actually remember how we did our arena stuff here. We need our arena to be initialized. So why isn't our arena initialized as the very first thing it does? That's just dumb. Yeah, so that's what we want there. Now, we don't actually have an arena for entities specifically at the moment. It's only for worlds. And so I don't really know how we want to really do that exactly. This may be something that actually wants sort of a sub-arena, right? I don't want to talk about this right now, but maybe talk about this soon. Let's start partitioning our memory space. So what I'm going to do right now is I'm going to go ahead and allow it to use Gamestate World Arena, right? But then I'm not actually going to do that. I'm just doing that temporarily because I don't want to actually explain some additional stuff that we'll explain in a bit. So not World Arena. Change to using the fundamental types arena, etc. All right. So what I want to do here is I just want to do the simple push stuff to allocate these things that we want, and they're, you know, pretty much permanent types. They just sit around forever. And so sim entity collision volume groups here. So this is the group. We're just going to push that on to the arena, and we've got we're doing it on the world arena for now, but again, that's not where I would probably do it eventually. So once we've got that, the group is going to have a volume count of 1 always, and it's going to have exactly 1 volume in it, and that volume is going to be equal to the total volumes for now. So we've got a push array, right? It's going to push the volume count on there. It's going to push one volume. And then what we're going to do is we're going to set the group total volume equal to, excuse me, equal to, I guess we're going to define that one. And then we're going to set the one volume we actually have to be equal to it. Because, like I said, right now we're not actually making multiple volumes. We're just using one volume. All right, so the total volume for this guy, let's go ahead up here into our sim entity collision volume. So we've got two things. We've got an offset P and we've got the dim. Those are the two things we need to set. The dim is really straightforward. It's just passed in, right? Dim Y, dim Z. The offset P, thankfully, is actually also very straightforward at the moment because the only thing we're making are very simple things. All it is it's offset off by half the height, right? That's all. So there's nothing else to it than that, and off it goes. So that's how we make a collision group, and presumably that should be fine. Now, of course, we're probably going to have a lot of bugs we've got to deal with, and so, you know, that's just something. Oh, yeah. If we actually want to reference the tile side meters, we haven't actually initialized that Gamestate stuff yet. And so I suppose what we probably have to do is set up our very initial, just our sort of very basic stuff like our tiles and that sort of stuff. So this all has to be kind of initialized at the outset, if that makes sense. So we'll go ahead and do that for now. Let's see here. So yeah. We're not totally busted. Our collision detection is still working. Our stairwell, on the other hand, is noticeably absent. And so we have some work to do there. Everything else seems to be working pretty well. Now, we did comment out the code for the stairwell. That is true. But you will notice that it should have still been drawing. So that is something that we have to go deal with. Yeah, so that's good. And I snuck in one other thing. I mean, obviously, I didn't mention it yet. Well, we may yet finish. We only have 7 minutes left. We may be able to finish stairwells as well. What I was going to say is I snuck in one extra thing. I don't know if you saw me do it. I was sly about it. It is true. But I got us most of the way there also for doing this. Because now flying entities just have their collision boxes offset from where they actually are, and they can still walk around on the ground just like everybody else. So this is kind of going to be free now, I think, for the most part. They'll just pass right over low walls because their collision boxes won't hit. That's all there is to it. So yeah, kind of cool. We get that for free. Knocks another to-do off the list. And that's always good. But for now, we need to go find out. Let's start with thing 1. Which is what happened to our stairwells. And I assume there's 2 places that this could be happening. One of them is here. Oh, you know what? We just probably never initialized that walkable dimension, did we? Right? That's probably what our problem was, I'm guessing. Because if we never actually initialized that walkable dimension. What did that just do? Okay, thank you. I'm hitting some errant keys tonight, let me tell you. So we have to actually set the walkable dimension to the area that we're supposed to actually hit, right? So yeah, makes sense. Anyway, so if we want to do that, I guess, I don't know what the dimension should be. I guess it should just be whatever the stair collision or I guess I should say whatever our collision, right, thinks is its total volume. It should just be that as a rectangle too. Seems reasonable to me. What do you guys think about that? I think that's roughly what we should do for that. And so we need a 2rectangle2 call. Right, something that converts a rectangle 3 into the corresponding rectangle 2, and maybe I'll say rectangle XY so that we can have other ways of slicing the rectangle up as a quick operation, right? And so what that'll do is that's just, you know, a real simple call. Again, it's a rectangle 2 returning, and it does a 2 rectangle xy, takes in that rectangle 3, and just returns that rectangle 2. And so what that does is it says, all right, you know, the result min equals a dot min xy, right? And the result max equals a dot max xy, and then that just, right, so that's just a conversion. It just takes a slice of that rectangle. So total volume, it's total volume dot dim is actually what I want to do there, right? Cannot convert argument 1 from v3 to rectangle 3. Why do I always think I need rectangle? Well, I still like having that function. I didn't need it. I didn't need it at all. That was all I really needed to do. Oh well. Well, at least we got to write 2 rectangle 2. But what are you going to do? So there's our stairwell back, so that's good. We still run into it, which is correct. And we still pass through it, which is correct, but we don't handle the overlapping case anymore because I if-zeroed that out. And so we do have a situation where that's going to be problematic. So let's go ahead and fix that. Let's see here. So inside my Handmade sim region, we need to re-enable this case. We can do the very simple thing by just testing the total volume. That would take no time at all, right? The total volume test is just this test. It's just entity collision. Excuse me. Yeah, it's entity collision total volume and entity collision total volume dim offset p, right? It's just making that offset. Should probably make a thing that just gets that volume back. We'll think about that. Think about that a little later. We have the test entity. We do the same test there. When we do the rect center dim for that, we'll just do entity collision total volume dot offset p, right? And test entity collision total volume dot dim. And I believe that would just do it with just, if we just want to do it with the total volumes, that would work. And so there we go. Can we jump? Oh, that was funny. I was trying to figure out if I can jump over the stairwell. You have to get up enough height to clear it, and I can't quite seem to. I need a little more jump. Oh, I can just double jump. Well, I got to be on top. I'll hit it if I'm on the bottom. Sweet. Awesome. So you can jump over the stairwell now. That's always fun. All right, so I think that's basically it. And we're just about out of time, so that's good. I want to go ahead and say handle multi-volumes here. So as we clean that up, we'll do that. We can do volume to volume overlap testing, basically. It's just a question of doing that n squared test again inside for each thing's volumes versus the other volumes. What I do want to do is I just want to finish up something here. We didn't do the null collision yet, right? So we have Gamestate null collision, and that's going to be just a thing where we've got a null collision that we make. And then what I want to do is when you add low entity, what I want to do is make it so that it initializes that, so that collision is always initialized to something, right? So there's always a null collision pointer in there so that people don't have to check to see if it's 0 so they won't crash or whatever, right? So what I want to do is I just want to make one of these that's specifically for null collisions. Basically represents no area whatsoever. Make null collision. And what that's going to do is that's going to set the volume count to 0, set the volume pointers to 0, and set the offset p and dimension all to 0 as well, right? So basically there's just nothing included in that region. So that's it. And I don't know if there's anything else. We could even do it making these negative. Making it negative would ensure, I don't know, I'll put it to do should this be negative? And there we go. All right. So that is, I think, the end of what I would like to cover for now. I like how, so we can't jump over it at the bottom because the stairwell's solid, right? But if we go up over it and it's just a hole in the floor now, we can jump over it, which is kind of nice, right? Yeah. It's weird what happens when we float down there. I guess, like, I don't totally understand what's happening there. It's like gravity doesn't affect us as fast as it should. I don't really know what's happening there. I don't know if we're having some kind of weird collision thing that happens there. Right? Like, why is that not going faster? Is that just because of the drag? Oh, that may be because of the drag. That's probably what that is. The drag is applied in 3D now, right? So the jumping is going to have drag. Yeah. Yeah. The jumping is going to have drag, isn't it? Let's take a look at that. Sorry, I said I was going to stop coding, but I lied. I went 2 minutes over. Call me a liar for 2 minutes. Tough crowd tonight. Gray face, no space. All right, let's see here. So, you know, basically we've got the drag being computed here. I feel like we want to knock out that aspect of the drag. So, you know, if we did this, right, that we just say there's no drag on Z. I don't know. What do you think? Because what I want to see happen is I want to fall down the stairwell, right? If I jump, and yeah, that's what's supposed to happen. Exactly right. Yeah. Boom. And then he lands on it. So that's what we want to have happen. All right. All right. Now we're actually done. Yes, I went over. No, there won't be as much Q&A as a result. But what are you going to do, right? That's just the way that goes sometimes. Please prefix your questions with Q:, and keep them to things that we did on tonight's stream or on a previous stream. It's about programming, people. It is about the programming that we're doing. You know how it is. Whee! I gotta jump up to that top level. I like the fact that we can jump up. We gotta have some kind of floor that you hit, so you can't just jump up to top levels. Like, here I am, one level up above everything. Let's keep going. There, now I've jumped up so far that we actually have a bunch of things that are clipped out of our region. Like, they're so far below us, they're not even in the sim region anymore. Right? Yeah. We gotta fix that ground level stuff. That's gotta be tomorrow's thing, because we're so close to having full 3D goodness here. We're pretty close. It's getting exciting. I'm a happy camper. All right. No questions. There are no questions. It is question free. Everyone thought it went perfectly. What can I say? Thank you. I appreciate that vote of confidence. Can we get a sneak preview of the fundamental types arena? I just want to make an arena for, like, so all it is, it's real simple, and I'll explain it in detail later, but all I want to do, right, is in our memory partition, there's going to be, like, constant stuff, right? Which is stuff like those collision definitions, and then there's going to be world stuff, right? And this stuff gets vaporized every time you start a new game, right? But this stuff doesn't. And so because there's no need, we could recreate everything every time, but because there's no need to recreate this, it's a nice optimization to say all of the constant stuff we do first at startup when you start the game, and then it just stays in that block footprint the whole time and is used by everyone. But the stuff that's specific to the world, this gets freed every time you finish finish a playthrough of the game. That's all. So it's nothing special. It's just we haven't talked about that stuff, and so I didn't want to just do it. I'd like to talk about it and and have some more time to go through it. So it's not rushed. Drive 137, what does besides the missed keys mean? I don't know what that means. Missed keys. Oh, because of my awesome typing? Yeah, Control Z made an appearance for the first time tonight. I'm surprised it hasn't happened earlier. But Control Z means suspend task in a Unix environment, right? And they've mapped it in Emacs and Windows to minimize. Because they did. I don't know. It's fine with me. It just... Let's see. Do we have any on-topic questions? It looks like we don't. You know, if I don't have any on-topic questions, that's okay. I'll answer off-topic questions for the 8 minutes we have remaining. If anyone does have an on-topic question, though, I will try to prioritize that. Like the sneak peek of the fundamental types arena, we already did that one, so that's good. What did I just watch? You watched me programming a game the way we do it in actual game programming in the real world. This is how game programming goes, and we're basically just doing exactly that. It's slower paced than how programming actually goes because I have to explain stuff and talk it through, which slows things down. But other than that, I'm basically doing almost exactly what I would be doing if this were work I was doing during the day to develop actual video games for real. So we're not pulling any punches here. I'm doing all the same stuff. I overcomplicate some things intentionally that maybe you could cut based on the game you were doing. So like, do we have to handle all this 3D stuff perfectly? And am I pushing forwards on some stuff that might not need to get pushed? Yes. But that's because it's, again, for educational purposes, and I want to give people a window into the 3D stuff because that would be the next logical step after Handmade Hero would be to start doing 3D engine programming as an extension of your 2D engine programming, because they're basically the same, but then the geometry gets more complicated. The geometry stuff gets more complicated. But otherwise, it's basically what that is. So what you watched was how we code. That's how we do it. I'm a little bit old school in how I program. So some people would have a lot more C++ness and be doing, inheritance and templates and stuff like that. But a lot of people wouldn't be. A lot of game programmers wouldn't be as well. A lot of game programmers program like I do. And I'm not the most old school out there, right? There's people who are way harder core than me and would bristle at some of the things I'm doing as being a little too new school, right? So, everyone has their own preference, and programming styles vary, and what you consider to be important and what you consider to be a priority varies from person to person, because sometimes there's no perfect right answer as to how to make a particular thing in a game, right? Let's see. So we have some on-topic questions here, so I want to parse those first. Let's see. So it looks like the on-topic questions I'd like to cover are, could you sketch what you did today visually? And the answer is yes, and I'll do that. And there was, would the ground collision be easier, have less issues if it was a volume instead of a plane? And the answer is, we haven't really done the ground stuff yet. And so what we're going to do with that, I don't know. I suspect we may make it a volume, but we may not. We may just treat it as a plane. I think that's probably not the interesting decision. The problem, if the reason that we have a to-do for a ground specification, like the reason I'm not happy with what's happening right now, right, is not really a collision detection problem, it's a specification problem, right? There's really no problem that we're having right now that has to do with the ground being a plane. The problem that we're having has to do with knowing where the ground is. So right now we just have entities in space, right? What we have to define a place, right now is we have a bunch of tree entities that we just placed in like a grid pattern, which was totally arbitrary, by the way. We didn't have to do that. That's just what we did. We've got a bunch of trees that are placed, and that defined a room. And since our collision detection is happening in 2D, that defines a nice room on a plane that we can walk around in. Everyone's happy. Problem is, when rooms start getting stacked on top of each other, the question is, where is the ground? Right? Where is it? And right now, we don't have a definition for that. All we do is say, well, wherever the camera's pointing, the Z position at which the camera's pointing, that's the ground. So literally, the ground moves with the camera right now, right? Which is totally not going to cut it. And so the question that we have to face is less about how do we mathematically deal with the ground once we know where it is, and more, how do we want to specify this? So one way we could specify it would be to actually just add entities in that say where the ground is. And if there's nothing there, then you fall through it. And that's how we would probably do it in a 3D environment, right? That's probably how we do that. In 2D, though, we have to ask the question, does that make a lot of sense? Because the common case in 2D is that there's just a flat ground under the room. And 99% of the time, that's probably what we're going to have. It's like ground under the room and maybe a stairwell, right? I mean, if you think about Legend of Zelda, Binding of Isaac, the games that I keep referencing, that's just we're trying to make that 2D dungeon crawly kind of a thing, they just don't have a lot of non-ground. It's just not that common. And so I wonder, does it make sense to treat the ground as something that we constantly have to say, hey, by the way, there's some ground? Does that make sense instead of just specifying where the ground isn't? Like, could we just always assume that there's ground, and then what we actually specify is where there's not ground, right? And so one example of this might be when we open up a sim region, insert ground levels at some known set of locations, and then assume that people will put in entities to say there's no ground at a particular place there. I don't know. It's on our to-do list. We'll look at it some more. We'll think about it some more. I don't know what the answer is. Right now, though, I think volume versus plane is not really a big concern. I think either one would be fine. Maybe we'll see that one or the other would be better a little further down the road. Right now, what concerns me most is just how do we specify it? How do we say where the ground is? Because right now we got nothing, and nothing is not an acceptable answer. Since you are handling Z, how complicated is it to have entity stacking with the current code state? It would not be hard at all to have entity stacking if you just want to, like, if I'm on top of an entity, I can walk on it. That'd be really easy. If you want to do stuff where, like, entities stack on top of each other in a physics puzzly way, like pushing things and, I don't know, there might be stuff where the physics would be nasty to do there. Are you using a memory manager? No. How are you laying out your levels currently, and are you going to make a level editor? This game is entirely procedurally generated, so we won't be making a level editor, but right now we don't do much procedural generation. We just have some little placeholder stuff in there. So right now it just generates a couple rooms, and that's it, just for testing. That'll be an entire block of time that we spend, probably a very significant block of time. Probably half the game development time, honestly, will be on level generation, because that's going to be one of the biggest important parts of the game. It'll be like the behavior of entities and objects, and level generation will be where we spend 400 of the 600 days or something, I would suspect. Just pulling a number out of my head, but is knowing big O notation important in game programming? Yes. Big O notation is important in any programming. You have to know how your code scales to... You have to know how many maximum things your code can handle before it totally breaks. The notation isn't important. It's understanding that n squared versus n versus log n versus n log n versus n log n squared, or whatever. It's understanding the behavioral, the scalability of the code is what's important, not the notation. The notation just happens to be how people write it. I think we're just about out of time. Let's see here. You mentioned further ways of partitioning collisions past breaking it up into regions. What would some of those be? Well, I don't really mean that. What I mean is we need to further break it up into regions. Like right now, we just have the sim region and everything in the sim region. What we want to do is partition the sim region into subregions that are strictly used for identifying things that might hit each other, right? So, two things in this space will be checked against each other, but a thing in this space and a thing in this space won't be, right? So it's just a way of keeping that n really small so that n is, like 5 or 10 at most, instead of 100 or 500 at worst, which is what we have now. And that's no good, right? Alrighty, let's go ahead and end that for today. Sorry the Q&A was short, but sometimes you start late and then the Q&A is short. So let's go ahead and close things down. I think we are in good shape here. Let's go ahead and close this down and end the stream. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. That was a good day today. We did some cleanup work that I thought was good, and I'm happy with how that came out. I hope you are too. If you want to follow along at home with the source code is included if you pre-order the game, so you can play around with it and learn game programming stuff by playing with the source code directly. So if you want to do that, you can pre-order the game at handmadehero.org using our lovely little pre-order button here. You can also support the video series by subscribing to our Patreon if you would like to. It's always very much appreciated. And we have a news and forum site that I would definitely recommend checking out. It's got a bunch of great resources on there. Forum, you can ask questions. It's got ports to Linux and Mac. It's got a community maintained episode guide, which is really handy. It's just, when you're trying to if you're new to the series and want to start back at the beginning. There's a lot of great stuff there, so please check that out. And finally, we have updated the Handmade Hero schedule tweeting bot to be daylight savings time aware even. How advanced is that? The singularity is near, people. This bot will soon become sentient and take over the world. I disavow any responsibility for that when you are running from a giant Handmade Hero tweet bot and you are screaming for your life and it is mercilessly grinding towards you with steel gears and an exoskeleton that is frightening and strapped with guns all over it. Just remember, all I was trying to do was make it tweet the time in daylight savings time. That was all I was trying to do. I wasn't trying to start the robot apocalypse. So I highly recommend checking that out while you can and before it turns on us. You can even follow that Handmade Hero bot to get its tweets sent directly to you. I strongly doubt whether it will care one way or the other when it comes to exterminating all the humans who was following it and not, but it can't hurt. It might take pity on people who followed it. I don't know. That said, thanks for joining me. I will be back here tomorrow at 8 p.m. Pacific Daylight Time. I'm going to say it right too. Pacific Daylight Time tomorrow. I hope to see you here for another round of Handmade Hero coding. Take it easy, everyone.